Ladies and gentlemen, welcome to It's Rainmaking Time. This is Kim Greenhouse. It is my pleasure to welcome George Taylor, the founder of Applied Climate Services, LLC in Corvallis, Oregon. He's going to explain to us why it's essential to understand the two basic types of climate scientists, the modelers and the empiricists, and how they think, how they work, and how climate science today is directly impacted by these two camps, if you will, of climatologists. Ladies and gentlemen, welcome George Taylor, who's been a meteorologist since 1971 to It's Rainmaking Time. Welcome to It's Rainmaking Time.
Thank you, Kim. Nice to be here.
Explain these two separate camps of operating and thinking, and explain to us why this has an impact on climate science as we know it today.
Well, let me start by saying that what I'm going to describe is a generalization, and not everybody fits neatly into these categories. It's sort of like saying there are liberals and conservatives, when in reality people have different combinations of characteristics. But as I see it, the two main kinds of climate scientists and describing the kind of work they do are those who are the data people or the empirical people and the modelers. The modelers use rather sophisticated numerical models, very similar to the ones that are used to predict day-to-day weather, and they try to simulate the atmosphere, and well, actually not just the atmosphere, but the Earth's processes. Actually, in order to simulate climate or weather, you have to not only include the atmosphere, you have to include the oceans and other aspects of water. You have to include what we call the cryosphere, which would be the frozen sections, and the biosphere, because plants and animals certainly affect climate as well. Once the simulation is set up, then what the modelers do is they'll adjust or tweak certain parameters. And the one that's most often tweaked is changes in greenhouse gases, primarily carbon dioxide. All else being equal, if you increase the carbon dioxide, you're going to increase the temperature by some amount. And these simulation models tend to show rather high amounts for future changes in those greenhouse gases. And therefore, those who are dependent on the models for analyzing the present and predicting the future tend to feel that there will be global warming if CO2 goes up, which is likely to do. Now, the other camp of people are the data people or the empirical people who look at actual real-world data, and they try to determine cause and effect relationships between certain parameters like ocean conditions and changes in sunlight and climate. Most of the state climatologists are data people. I'm a former state climatologist for Oregon and am very familiar with that kind of process and that kind of analysis. And most of the people that just look at the data are a lot less alarmed about future climate and future warming than those who are modelers.
How do these two camps of processing information impact what we're receiving as being the declaration of global warming, which is now packaged as climate change? How does it affect what we're even referring to?
I think to answer that, I would have to dip into the political bag, because one of the things that's happened in climate science is it's gotten very much enmeshed with politics, and whenever science and politics mix, you tend to have politics slopping over into the decision making that's involved in science. Science has a lot of uncertainty, a lot of gray. There are a lot of unknowns, and if you study the history of science, you find a lot of cases, a lot of subjects where science was pretty firmly believing a certain thing that later on proved to be untrue. And that's part of the uncertainty of the gray area in science, is to acknowledge that there's a lot that we don't know and we don't understand. Being especially a climate and weather guy humbles me, because weather and climate guys are wrong quite a bit of the time. And And that's true in just about every science. Politics, however, needs black and white, yes, no answers to questions. And I think when scientists get trapped in this yes, no, black and white kind of world, they tend to get rather exclusive and rather stubborn, and they forget about the uncertainties. This whole field of climate science has gotten so enmeshed in politics that it has carried over into some real polarization. You tend to have scientists on one side or the other of this global climate issue, rather than us all talking about the uncertainties and agreeing to get along.
When the public perceives when climatologists say this or that, how is it possible that the final word on climate is the official word, if in fact there's two totally different camps in which, or paradigms in which, they each come to analyze data? One is through simulation, and of course, I did a piece on this regarding simulation, which is garbage in, garbage out. It depends what's put into the simulation generates what you get out. Yeah. So unless the public knows what is being put into simulations, it's hard to just blindly agree that the official stated condition of concern is this warming, since we've had record temperatures of cooling in the last 10 years. Do you understand that?
I understand that. I'm not sure what the answer really is. I mean, one of the questions that I get a lot when I give public talks, and I give a lot of public talks, is, well, you say this and somebody else says this. How do I know who to believe? And it's tough to know who to believe. Why should they listen to George Taylor instead of James Hansen? Why should they listen to James Hansen instead of George Taylor? And James Hansen is a fellow from NASA who believes differently about the human component than I do. It's a tough thing to know, and I think again with the political pressure, I think scientists are less willing to admit that they have reservations or uncertainties about this issue, rather than just saying, this is what I feel, and I might be wrong, and these are the reasons why I might be wrong. There's a famous physicist. He was a Nobel Prize winner, Richard Feynman, and he once said the finest scientists are always trying to prove themselves wrong. And I think it's human nature to do just the opposite, and I recognize that in myself. I really try to justify my own decisions, my own opinions, my own wisdom and knowledge, and I think it's easy to get caught up in that, and probably a big mistake.
How come it is that science appears as if it's been co-opted, and that you have this huge peer pressure to agree that humans are the cause of a condition called climate change, when climate change has been distorted as a concept, is something that scientists always agreed is something that goes on over long periods of time. But now all of a sudden, we're connected to being the cause of something that's a natural cyclical phenomenon, A, and B, the Earth's been cooling for 10 years, and yet I watched Bindi Irwin, who's been asked questions about global warming, and I love Bindi, and I loved her father and her mother and the work that they do, but it's almost like global warming has been thrown into this big package. If you love the Earth, then everything global warming that's wrong with the Earth, you get involved in global warming. Instead of its own distinct niche of dialogue, it's the soup for everything. Do you see that?
I do see that, and what I see also is some real part of this polarization, I guess, is distrust on both sides of the issues, distrust of one side for the other, and I've certainly been the target of what you might call witch hunts, and certainly a lot of criticism for my skepticism about the human component of climate change. I've been skeptical about this for a long time, since the mid-1990s. And
what does that mean when you say that? I want to take you back for just a minute. What does that mean when you